Yeah, hello. Good evening, everyone, or good afternoon, everyone. How are you all? Just confirm once when you can see me, you can hear me, you can see this presentation, as well as there is no echo in the voice. Just confirm once. Yes, everything is fine, right? Okay. Sir, I could not complete 3 assignments as I had to do college assignments, so I did not get the time. 6, 7, 8 are remaining. Please do complete them. If it is due date is passed, then please do contact the NPTEL team. They would be able to guide you. If some facility is there to submit the assignments after the due date. Just please try to complete everything due in time, okay? So that you will get good marks, enough marks. Okay. Yeah. Is it clear, Rolly? Are you clear? Any issue is there? Okay. Yes. Today I have to cover a lot of things, so I'll gear up accordingly. Okay. I'll not repeat much. That if it is clear to you, it is clear to you. Okay, you can just stop me. You can unmute yourself. You can ask wherever you want to ask. If some doubt is there, then please do ask. Okay, don't let me jump or don't let me come to the next topic. Okay, if you are having any doubt, okay, then please do ask. Yeah, yeah, I will start, Rishi. You are too excited.
Yes,
Yes, you are too excited in the beginning, but your excitement level comes down afterwards. Okay, I'll start, no problem. Just a second. Lot of students are joining. Okay, let us start. As you all know, Rishi, your mic is too noisy. Okay, I am muting itself. Your mic is too noisy. If you have to ask something, then please do write it in the message. Okay. Or otherwise, after my explanation is over, then you can unmute yourself and ask. Okay. Yeah. Okay. Yes. Good afternoon, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department, IIT Kharagpur, and I'll be taking your live interactive session for the course Problem Solving Through Programming in C. Okay. This course is taught by Professor Anupam Basu from IIT Kharagpur. Okay. And uh, what we'll be doing in this particular session, that we'll be solving some of the objective type of questions based on the previous week's content in front of you all. Okay, and then I will go deep into the explanation. Okay, that is what we are going to do. Yes, let us start because there is a lot of things to cover based on the previous week's content. Okay, yes, the very first question for the present session is this one: what is the worst case complexity of selection sort? Okay, and your options are big O notation n log n, big O notation log n, big O notation n, and big O notation n square. And please do try to answer. Okay, and Rishi, answering to your never ending curiosities, I have joined perfectly on time. I can join lately also. 5-10 minutes delay with humans can happen, but I have joined exactly 1-2 minutes before. Okay. So I am not going into a chatter, and I am not going to argue with you. Please mind yourself. I am a teacher. I have much more experience than you, so you just have some respect. Okay, don't tell me when to start, when to end. Okay, as well as please don't interrupt, because it is a loss to all the students. Okay, you are in your own joyous mood, you want to have something, have some conversation. Other students are pretty serious. Okay, they don't miss the classes, they have a good amount of intellect, so let us study. Okay, I'll not be taking any of your considerations, I'll not be jumping into your dirt. Okay, you keep on chatting whatever you want. Okay, yes, now please do try. All of us should concentrate. Okay, what is the worst case complexity of selection sort? And only Roli has answered it as big O notation n square. Okay, rest of the students, please do try to answer it. Okay. Yes. Okay, three students have answered it as big O notation n square. Okay, good, great. Yes. See, a lot of things are there to discuss. Okay, nearly a whole of the big O notation as well as all the aspects I'll try to cover. But I'll be not asking you twice and thrice. If you are having any doubt at any point of time, okay, please do unmute yourself, use the chat box. Okay, try to answer. Okay, yes. Yes, try to give your opinion. Last week's content was wholly based on this big O notation. Okay. So, big O notation is a very important concept in computer science. It allows us to judge and manipulate the complexity of various algorithms. Okay. From this particular concept onwards, whatever the concepts will be taught to you, they'll be just very, very useful for you, even if you will join the industry, even if you will have some research, if you'll be doing some research, it would be very, very useful. Okay. So that is how things will proceed from here onwards. This week's onwards, some advanced concepts we'll also deal with it, will with them. Okay, so week 9, 10, 11, 12, 4 weeks are there. Okay, so be very careful with the video lectures also. Okay, as well as with the content which I am providing to you. Okay, yes, try to be punctual, try to focus. Okay, because our examination is also very near. Okay, and these concepts are pretty advanced questions. These are very, very useful. Okay, even if you are going for some high end research, even in PhD research also, these concepts are very, very useful. Okay, so if your basics are strong, then very easily you will be able to sail through. Okay, this is the thing. What is the worst case complexity of selection sort? Three students have answered it as D. Okay, yes. Okay, indeed, the correct option is big O notation n square. Okay, this you have to just think. Okay, the worst case complexity of selection sort is big O notation n square. Why is it so? I am just going into the concepts. Okay, just bear with me. Take a copy pen and write down each and everything which is there. Okay, and then if at the end of every question you are having any doubt, then try to ask me. Okay, using the chat box or using the unmuting yourself. Okay, if your mic is not too noisy. Okay, yes. Yeah, these were the instructions from my side. Now I'll not repeat anything. Let us move on. Okay, this selection sort, it's a comparison based sorting algorithm. Sorting algorithm means either an array has been provided to you. Okay, this array you have to just sort either in ascending order or either in descending order. Okay, that repeatedly selects the smallest element from the unsorted part. Smallest element from the unsorted part. This is very, very important for you to understand. Smallest element from the unsorted part. this will be taken, okay, and you will be swapping it with the first unsorted element. Okay, this is very, very important for you to understand that I'll be selecting the smallest element from the unsorted part, and then I'll be swapping with the first unsorted element. For example, let us take an array. It is 64, 25, 12, 22, and 11. Okay, all these elements are there. They have been arranged in any order. Okay, neither it is ascending, neither it is descending. So selection sort is a comparison based algorithm. It will try to sort this array in ascending order, okay, or either in descending order. How it will do it? It will first find the smallest element. For example, here, this in this case, it is 11. It will swap that element with the first unsorted element. Okay, so 11 is swapped with 64. That goes with your step number 1. Okay, then you find the next smallest number, which is 12. Okay, then you try to swap it with the next unsorted element. Okay, so 12 is sorted with 25. Similarly, you find the next smallest element, which is 22. Now you swap it with 25. Okay. Now again, you try to find the next smallest element, which is 25. So this sequence is already correct. Okay. So this is the work behind process of selection sort algorithm. It's a comparison based sorting algorithm. It will repeatedly select the smallest element of the unsorted part, and then it will swap with the first unsorted element till the entire array is sorted. Okay, now you have to find the complexity. You have to find the complexity, time complexity for this particular operation. Okay, how you can do it? How many it you just have to analyze how many comparisons and swaps the selection sort is performing. Okay, first of all, in the first pass, what you are doing, you are comparing n minus 1 elements. Okay, you are comparing, you are taking one element, so n minus 1 element are remaining. Okay, so you are comparing that particular smallest number with n minus 1 element. Then two particular elements you have sorted. Okay, so now you are left with n minus 2 elements. Now you will take another smallest element, you will compare with n minus 2 elements, n minus 1 minus 1. Okay, then similarly in third pass you will be comparing with the n minus 3 elements. Okay, and in the last pass you are only left with one element. Okay, so the total number of comparisons which are there, okay, which you have to make would be n minus 1 plus n minus 2 plus n minus 3 till 1. And you already know that what is the sum of all these numbers? N into n plus 1 divided by 2. Okay. So n here in this case is n minus 1. Okay. And n minus 1 plus 1 is n. So n into n minus 1 divided by 2, that is the entire sum. Okay, and you must be knowing that while we are calculating the complexity, okay, or we are counting the swaps, each time we find the smallest element, we swap it with another first unsorted element, and in our worst case we may have to do big O notation n number of swaps. Okay, so the dominant factor of your n into n minus 1 divided by 2 that you have to take while forming or while telling the complexity of that algorithm. So the dominant factor is n square. So the complexity, worst case complexity would be big O notation n square. Big O notation n or big O n is the smallest number, smallest, simplest complexity. Largest complexity which can be there is big O notation n square. Okay. How this particular concept we are dealing? Okay, let us look. See here, other options were big O notation and log n. Sorting algorithms like merge sort, quick sort already covered in your this week's content. Okay, they particularly are having this type of complexity, which is big O notation and log n. Okay, big O notation log n. This is the logarithmic complexity, means the problem size is reduced significantly at every step. For example, in case of your binary search, in case of your selection sort. Okay, big O notation n, when your selection sort will be not always comparing to other elements, it will make it much slower. That is why we go for big O notation log n. Big O notation n, no, it is not a complete option, because it means that the entire complexity is dealt in a single pass. Okay, so no, it is not there, because already we are getting a term of n square. That is why, due to the nesting of the loops, which you will just see in the selection sort algorithms code. Okay, so that is why it is the big O notation n square. Okay, selection sort finds the smallest element in each pass and swaps it. Always requires big O notation n square comparisons, even in the worst case. Hence, the worst case complexity was being asked. Okay, so hence the correct option is big O notation n square. This was regarding this particular question. Now I will tell you in brief how you can find the complexity, the time complexity, okay, or any algorithm's complexity in detail. To determine an algorithm's complexity, we have to analyze the number of operations which are getting executed in relation to the input size, which is n. Steps to analyze complexity include counting the number of operations, identifying the loops, recursions, or the key computations. Then you have to identify what is the growth rate, okay, as n is increasing. Then focus on the dominant term, which is ignore constants and lower order terms. And then you understand logarithmic growth, okay, or how particularly in general the algorithm is growing. For example, in case of logarithmic complexity, if the complexity is log n, how do you achieve it? How do you find out that it is big O notation log n? Okay, this you just try to see here. If you would be seeing this particular problem, okay, which is binary search. Okay, what is binary search? Binary search is repeatedly dividing the entire search space in half. Okay, so this is the entire code, C code for binary search. Okay, here you can just see that how things are happening. First of all, we are finding the middle index. Then we are checking if the key is that particular element which has to be found out. Okay, it's a search algorithm. Two types of basic categories are there. Search algorithm. Search algorithm means in an entire array we have to find that particular element, as well as sorting elements. Sorting algorithms are there. Sorting algorithms means you have to either arrange the entire array in ascending or descending order. Okay, yes. So first of all, you have to find the middle index. Then you have to check if the key is at mid. Okay, if key is greater, then you either have to proceed with the left half. If key is smaller, then you have to ignore the right half. You have to just judge whether you have to go for the left half or right half. We will just in brief, I am telling you here, there is a full scale example to it. Thereby you will understand it in much more detail. Okay, now here, as you all know, that from the main section we are just passing on the everything to the our first function, which is binary search function. Okay, so this is how you just push on a sorted array, then you try to find out that whether element it has found or not. Now you try to analyze this. Initially we are having n elements. After the first step, your entire search space is reduced to n by 2. Then your in the second step, it is further reduced to n by 2 by 2, which is n by 4. Then after the k steps, the search space becomes n by 2 raised to the power k. Okay, so 2 raised to power k is equal to n. Okay, so k equal to log base to n. Hence the binary search algorithm is having big O notation log n time complexity. Okay, this is the thing. Similarly, if you will try to see here in this particular example, next example, okay, instead of multiplying x by itself n times, we reduce the exponent by half in each step. Hence, the in case of your recursive power function, what it does try to do, it tries to just calculate x to the power y. Okay. Base case, as you already know, if some integer or some is there, then x to the power 0 is 1. Here we are returning 1 exactly, directly, no problem. Else we are making a recursive call. Okay, recursive call means function inside a function. Okay, so that we are just supplying here. Okay, recursive call we are making. If it is even, we are multiplying half results. If it is odd, we are multiplying extra x. Now you just see this particular example, as well as my voice is little bit breaking for you all or just for Rishi. Please, every anybody else, please just try to confirm, is my voice breaking or not? Yes, it is not breaking. Rishi, you can rejoin. Okay, you can rejoin, thereby your thing will be over. Yes, now you try to just see here why this particular thing is big O notation login, how you approach a code, how you approach everything. Okay, then you just try to see what is the actual complexity. Okay, two students are saying it is not breaking, that is why I am not taking any step. Okay, it is case with you, then you can solve it on your own. Okay, either you can rejoin, you can shift to some another area where network is good. Okay, because from my end everything looks fine. Okay, here I am using three particular devices. I don't think so there is any technical glitch. Okay, yes, why is it login? Because you are trying to uh, divide the problem size by 2 at every step. If y is 10, for in this case x raised to power y, simple thing is there, then you are computing 2 raised to power 5. Okay, okay, 2 raised to power 5, then you are calculating again reducing by half, 2 square square, then you are computing 2 raised to power 1 power 2, and thereby you are achieving base case. So every time you are just increasing it at half each step. So thereby the entire complexity will be log n. Okay, this is the thing. I know it is somewhat difficult to understand, but later on I'll take multiple examples. Thereby everything will be much more clear. Okay, and thereby you can look at any algorithm and you can find out what is the big O notation, what is the time complexity. Okay, nature of time complexity, if in summary I have to just tell you, big O notation 1 is there in those cases in which no loops is there, just few operations are there. For example, I am accessing any element of an array. In that particular case it is big O notation 1. Big O notation log n is there when your problem size is halving at each step. Okay, so in case of your binary search, in case of your fast exponentiation, this is the thing. Big O notation n is there when single loop through is there through n elements. For example, in case of linear search. Okay. Big O notation n log n is there when you are recursively dividing as well as you are merging elements. For example, in your merge sort as well as in your quick sort. Big O notation n square, as we have seen in this particular case only, nested loops iterating over n. In case of your selection sort, in case of your bubble sort. Big O notation 2 raised to power n in those particular cases in which exponential recursive calls are there. For example, Fibonacci series. Okay, exponential recursive calls is there. I told you what is exponential recursive calls in my previous lecture. If you are having still any doubts, then please go through it. Okay, the recording as well as the PDF is available. Whatever suits you, you can go through it. But exponential recursive call, you just have to understand that whenever function is called inside a function and multiple copies of that particular function are getting created at each step. At two steps, if two copies of same function are getting created, then thereby the copies of the function will increase exponential. Hence, it is the case of exponential functional complexity. Okay. And in summary, all these particular points are there. Okay. Which is good, which is bad. And you just have to decrease the complexity. Please do keep it in mind. Okay. Don't say ki sir, I'll increase the complexity, thereby algorithm will be performing much better. No, always you have to decrease the complexity, decrease the time complexity. Okay, that is there. Okay. And one more doubt in initial years students have, that sir, if the code is too big, it is too lengthy, then will it be having more complexity or less complexity? No, code may be of 2000 lines, but it might still have less complexity than a code of one line only, because the complexity depends on the type, on the coding. Okay, how a programmer is writing the code, that will either increase or decrease the complexity. If you are nesting a loop, if you are iterating through the loop, if you are going through one element at a time, it depends all on you. Okay, this is the thing. Let's understand for once again. Okay, selection sort, how this particular thing is working, outer loop as well as inner loop, I have told you. Then we have calculated entire thing, approximately it is coming n square, hence we are saying the complexity is big O notation n square. Okay, why is it not n log n? I told you. Why is it not log n or n? I already told you. So here in brief it is described. Okay. Yes, big O notation is a very important concept which focuses on growth, it focuses on worst case scenario, it focuses on asymptomatic analysis. This asymptote, it is taught in engineering mathematics too. Okay. Big O notation is an example of asymptotic analysis. Asymptote means tangent at infinity. Okay, this is the concept. Meaning that we are interested in what is happening to our algorithm behavior as the input size tends to infinity, not necessarily what happens for small inputs. We are not concentrating ourselves to the small inputs. We are concentrating ourselves on to the large inputs. That is why big O notation and concepts like this is dealt. This is a very, very important concept, particularly in those cases in which the computation complexity has to be minimized. The operation has to be carried out in the least possible time. In those particular cases, this is very, very important. Okay. Big O notation one is there for constant time. Okay. For you are, for example, you are accessing an element of an array. In case of your big O notation log n, okay, it is logarithmic time. This particular thing is there when algorithm divides the input problem into smaller subproblems at each step. For example, in your binary search or sorted array, big O notation n is there in case of your linear time. Big O notation n log n is there in your linear arithmetic time. Okay, for example, in your merge sort or quick sort. Then n square is there in your bubble sorts, insertion sort, selection sort. Each and everything we'll just deal with it. Okay, as and soon it will come in the lecture. This is going to be a long lecture. Okay. Then big O notation 2 power n is there. As I already told you, in case of TSP, traveling salesman problem, problem of towers of Hanoi. These all are examples. These are real real world based problems. So these are having the complexity of big O notation 2 power n. Okay. Then this is the worst complexity, which is big O notation n factorial. This is the running time grows factorially to the size of input. The algorithms are generally impractical for most of the applications. If in case you are finding that the complexity has is just n factorial, then it is almost impossible to solve it within a stipulated amount of time. But we are trying to solve it using some high computation or edge computing devices using supercomputers. We often try to solve this. For example, traveling salesman problem is a very important problem that has been much sought problem. Okay, because it is based on a real world problem. Okay, real world scenario. Now it has been calculated using the help of supercomputers to for much higher number of cities. Okay. In brief, if I'll tell you about the traveling salesman problem, as the name has suggest, that if suppose n number of cities are there, okay, and a salesman has to one particular salesman is there, and he has to deliver m number of envelopes to n cities or n persons. So how he should approach so that he would be able to deliver all the m envelopes to n cities in the least possible time. That is the statement of the traveling salesman problem. Okay. This is a very complex problem, but now it has been solved using much faster, quicker algorithms. Now you can even find the solutions to this problem in nanoseconds. Okay, this is the thing. How we are doing? How is it possible? Just by knowing the concept of big O notation. First of all, we have to judge the complexity. Then we have to reduce the complexity in the least possible manner. Okay, to the least possible manner. That is the thing. Now, how to determine big O notation? That in brief, I have told here once again. Identifying the dominant operation. Look for the operation that are executed most frequently, usually loops or recursive calls. Determine the overall time complexity. Okay. For example, in case of your 5n, the big O notation is n. This suggests that you have to ignore constants and lower order terms always. When you have to find the big O notation, you just have to completely ignore the constants and lower order terms. In case of your n square plus 3n plus 10, the only the complexity will be n square. Will not add n into it. Okay. Then you have to analyze how many number of operations is there. Okay, which will be called as a function of n. Then big O notation, use the notations above based on the function scales with n. Okay, analyzing a simple loop for int I equal to 0, I less than n, I plus plus. Loop is running n number of times. Okay, so hence inside the thing, it is having the complexity big O notation 1. Okay, because it is accessing one particular element at each point of time. So the time complexity inside the loop is big O notation 1, but overall the time complexity is big O notation n because it passes through entire total number of terms, which is n. Okay. It's a very important concept. Already I have told you, because of the algorithm comparison, because of the performance prediction, because of the code optimization, because of the system design. Okay. So this is the thing. Let's move forward. Okay. Try to just solve this particular question. What is the correct order of insertion sort in ascending order of the array? Okay. So four particular options are there. It is a easy question. Don't commit any mistake in it. Okay. Yes. Try to solve. Take your time, no problem. Yes. What happened? Is it too complex for you to understand? Yeah, C, good. Very good. C, good. Okay. Yes. Yes, right. C 10 times, Rishi. It will still be C. Okay, good. Yeah, Giri Prasad is saying A. Very good. Three students are saying C. Okay. Yes. B. Good. Okay. B. Okay, good. Very good. A is there, B is there, A is there. Yes, Anindita is saying B, A. Good, very good. Rajesh is saying A. Then Giri Prasad is saying A. Okay. Final answer is C only, sir. Okay. Very good. At least Rishi have some manners. False accusations which you are making on me because you are sitting in an online medium. Try to think that how it will hurt somebody. At least have some human point of view. Just typing in the accusation, sir, you joined lately, you are starting lately. Wait, I have joined perfectly on time. You were the first person, and now you are just making false accusations. How badly it will hurt somebody. Your entire life is not based on lies. It should be based on truth. You were the first person which I allowed in the meeting, and we both joined 3 minutes before 3. How come is it late? And genuinely start after 5 minutes, so I give some time to students for joining. They are leaving. I have to keep in mind that all students are there, not only one person whose name is Rishi Triple E. I don't know what is the meaning of Triple E. So only if I'm not giving you personal coaching, na. This you please keep in mind. Okay. I'm very fed up with you. Really, man. No, no, I'll not leave because you don't want me to leave. You are behaving too childish. I know. I can leave it. Okay. But don't try to do these type of things. False accusations, if you are just making one teacher, when you will become a citizen in the society, then how much false forgery you can do. I am very worried about you. Okay. Don't do these type of things. Behave like a student first. Okay. Very sincerely, I respect you all. You have joined. I know everything, but don't make false accusations. At least, okay. Behave yourself. Be a student. Behave like a student. That is only what I want from you all. Rest all students are very good. They want to listen. They want to do. They practice also. I know. I get a lot of emails from students. They ask doubts also. Gave you email also. Everything I gave you. But you were the from the very first class you were trying to tease me. Had it been an offline class, na, then I would have. Yeah, last session I joined 2:45. There are some issues. Okay, but the session is from 3 only, right? I joined perfectly in time. Don't try to annoy the teacher, okay? Because if it had been an offline class, then I would have definitely taught you something very indifferent, okay? Please, from your next class or from this moment onwards, try to behave like a good citizen first, okay? Thereby you will excel in all fields of life. That is what I want, okay? And just that is the only thing which I can say. It was there in my mind, so I just thought that I should teach you separately. Okay, so that is why I said it. Now this topic is over. Whatever you want to write afterwards, write. I will not take anything into consideration. Okay, whatever you feel, you can say. Yes, here we were, and what is the correct order of insertion sort of the array? And you have been given an array as 83594. Okay. So this particular array is there, 83594. This particular array is there, and we have been asked that what is the correct order of sorting in ascending order. And I'll have a hearty congratulation to Anindita, Rajesh, and Giri Prasad, and all the students who have answered it A. Rest all the other options are incorrect because here we are telling about the insertion sort. We are not randomly casually sorting. We are sorting it in a very specific manner. In the examination, the options might be even more confusing than this. Okay. Correct option is this A only, 38594 to 35894 to 34589. Okay, that is the particular thing. This you have to just keep in mind that we are not sorting casually. Most of you have answered it C. See, try to see the C option. 38594 is there. Okay, how come it has been there, then after that 34589 is there? So entire pattern or entire logic is missing here. But if you will see the first option, I'll tell you the entire logic. It is the most logical as compared to the when it comes to the insertion sort. Let us see the explanation. Insertion sort, very simple sorting algorithm that works similarly to how we sort playing cards in our hands. Okay, it builds the sorted array one element at a time by picking the next element and placing it in the correct position. How insertion sort is working? We are given an array which is 83594. The first element it will take, first element is already sorted, no change it will take. Okay, it will take array as it is by assuming that the first element which is 8 is sorted. So 83594 it has taken. Now when it comes to step 2, it will compare 3 to 8. It was 83594, it will compare the first two elements first. Okay, so as you know that 3 is less than 8, it will try to swap. Okay, then another comes to 3 and 8 is done. Now now it comes to the next element. Next element is 5. So it will compare 5 and 8, it will compare 5 and 3, and it will insert 5 between 3 and 8. Now it is 9. Okay, now it comes to the next element. So it will compare 9 and 8. Okay, 9 and 8 is already sorted in ascending order, need not to take any shift or any change. Okay, now when it comes to the last element which was 4, so comparing 4 with 9, then comparing 4 with 8, then comparing 4 with 3, and in total you are just shifting it at the appropriate place. So it will be 3, 4, 5, 8, 9. In total there were three particular steps: the initial array, after that 38594, then 35894, then 34589. This is reflected in the first particular option. Okay, so this is the case of insertion sort. See, don't see the options and directly jump into ki sir, I'll see the options and I'll just try to figure it out. Try to do the insertion sort with the given array in the particular fashion. Then only you will be able to achieve at the correct option. Just remembering the correct option, remembering this particular fashion and this particular array won't help you in the examination. Complex questions might be asked. Okay, that is why from here onwards I am telling you, be very serious. Try to revise at least once, twice these particular questions. Try to understand the logic. Everything is there in PPT in a very simple language. I have removed all the complex things which I have previously added at the starting, because now I think that everything should be taught in a very simple manner. Okay, that is the thing. For two questions only, I am taking more than 45 minutes. This is the only reason, so that you understand at least. Okay. Now you try to see here, this is the particular code of the insertion sort. In case of your insertion sort, you are getting a particular array and the size along as the parameters ARR as well as I and N. The current element to be inserted, that is found as the key. Okay, then shift the elements that are greater than key in the right, or inserting the key at the correct position. Okay, then there is function to print the entire sorted array. Okay, so this is the main function from which we are getting the input. Okay, we are calling input to the we are giving input to the insert selection sort insertion sort function. Okay, this is the entire explanation of the code. Okay, looping through all the elements starting from index 1 The first element is already considered sorted, okay, as I have shown you in the array also. Then pick the current element, which is the key, and compare it with previous elements. If the previous elements are greater than key, shift them right. Place key in the correct position. Continue this process until the entire array is sorted. Okay. So step execution is there for this particular array, and we have gone through each and every pass. Hence, the final sorted array is 3, 4, 5, 8, 9. Complexity, if you want to find it out, the minimum complexity is n when you have to visit each and every element. The worst case is there, in which entire n elements you have to swap n number of times. So n into n is n square. Okay. These are the best and the worst case complexities, as well as the code of selection sort. After the exam, after this particular class is over, try to see this particular code, how this is functioning. Already taught much in great detail in the theory. But if you have not gone through, or by somehow you have missed the theory lectures, okay, not able to understand, then watch through here. Okay. Let us move forward. Okay. When the binary search is best applied to an array. For a very large size array, for the array which is sorted, when the array elements are mixed data type, when the array is unsorted. Okay. Try to answer this particular question. Okay. Yeah. Yes, yes. My voice is little bit breaking, but no student is complaining. Hence, your internet is somewhat different, because on three devices simultaneously I am monitoring my audio quality, video quality, everything. And if the internet at IIT Kharagpur is down, then I don't know from where I need to fetch the internet. You are working on cellular device, my dear. I am working on LAN, and that LAN is directly coming from Pune to here. Okay. Please check your internet connection, my dear Rishi. Yes. In my voice, if any problem is there at any point of time, okay, then please do tell me. In case of my voice, in case of video, okay. But if to one student a problem is there, then I cannot help. Okay. Yes. Yes. See here, Saurav is saying that there is no problem. I also think that there is no problem, as I can clearly see the audio input. No, nothing is there. Monitoring the audio input. Okay. Yeah. One, two, three. Three particular students have answered it is B. Okay. When the array is sorted. Yeah. Okay. Any more opinions? Yeah. Okay. Opinion is B. Good. Okay. One more opinion. B. Good. Very nice. Indeed, it is B. Binary search. Binary search is best applied in case when the array is sorted. Definitely. What is binary search? What is the code? Okay. Sir, can you please send the notes link? Okay, I'll just send. Okay, just a second. Give me few seconds. I'll just send. I just forgot to send it in here. Yes. This is the particular link. It is having the link to your this particular slides, as well as to your in particular the YouTube recordings also. Okay. So both the facilities are available here. Okay. So you can always see the notes as well as you can walk through the video lectures, YouTube recordings. Okay. Yes. Binary search is an efficient searching algorithm. It works by dividing the entire search space, which is the whole breadth of the array, in half at each and every step. It is significantly faster than the linear search, because in case of linear search, you have to visit each and every element in a stepwise manner. It has a requirement. Single requirement is this, that binary search only works when you will give it a sorted array. For a very large size array, no, binary search is efficient for large size array, but it works only if the array is sorted. Okay, not that much efficient because it is still having a complexity of log n log n. Okay, if it is unsorted, it becomes n log n. If it is sorted, it becomes log n. Okay, binary search is fast for large arrays, but its only condition is the requirement, which is a case of sorted array. It takes sorted array as an input. Okay, when the array is sorted, this was the correct option. Binary search requires a sorted array to work correctly. Okay, if the array is sorted, okay, then binary search finds an element, big O notation, log n time. Why? Sorting is a precondition for the binary search. Correct answer is sorting is mandatory for binary search. If it is a multiple select question, in MCQ, multiple choice question, you have to choose the most appropriate option, which was B. But in case of your multiple select question, even A is also correct. For a very large size array, yes, you can apply it. Okay, prior to the condition that you are given, it is sorted. Okay, so complete sentence is not there, but still it is correct. Okay, partially correct. Okay, yes. Then when the array elements are mixed data types, no sorting algorithm will work for it. Okay, in case of your mixed data types, because integer can be only compared to integer, float can be compared to float, character can be compared to character. Okay, so any comparison can only take place, or well-defined comparison can only take place in case the it is a non-mixed or a uniform data type. Okay, this is the thing. Now you will say, sir, in the output questions you were comparing characters also with the numbers. Yes, I was comparing, but I gave you the prior condition that you are comparing a particular character with a integer, not with a float. Okay, so character corresponding to a character, there is an ASCII code. So directly the C compiler will convert the character to its particular ASCII code. Then the comparison will take place between two particular integers. That is the thing. Okay, so binary search is only useful when all the elements are of same type and it can be compared. Okay, this is the thing. So when the array is unsorted, no, it will not work. Hence, it is a not a correct option. Okay, this is the thing. Yes, when the array is sorted, definitely your binary search will function 110%. Binary search is a very efficient search algorithm. It relies on a crucial prerequisite, which is sorted data. How is it particularly working? It is working on the concept which is divide and conquer. Okay, binary search repeatedly divides the entire interval in half. This we'll see through an example as well as through the code. Okay, it will try to find out the midpoint. It finds the middle element of the current search interval. It compares the target value with the middle element. Okay, it will try to compare. If the target matches the middle element, search is complete. If the target is less than middle element, it will discard, move to the right half of the interval, else it will move to the left half of the interval, and hence it will repeat. Okay, so why sorting is essential? The efficiency of binary search comes from its ability to discard half of the remaining search space at each step, only possible when the array is sorted. That is why the only correct option is B. Okay, because only in case the entire array is sorted, it will try to find out the midpoint. Then either it will try to move to the right hand side or to the left hand side, then carry out, find out another midpoint, then either move to the left hand side or right hand side. But the prior condition is that it should be entire array should be sorted. That is why the option which is correct is B only. Okay. As if the elements are not ordered, it is not possible to guarantee that the target value is in the lower or upper half of the current space. For example, if the array is unsorted and a midpoint is chosen, it is not possible to know whether a value that is larger than the midpoint is located in the left or in the right. Okay. Another options were for a very large size array. No, it is not correct. Okay. Binary search is efficient for large arrays. Size of the array does not matter as much as the sorting order. It is can be used for small, medium, large size, but the prior condition is this one. Okay. When the array elements are mixed at a time, no. Then when the array is unsorted, no, it will not work. Okay. Hence the correct option is when the array is sorted. Okay. Yes. Moving to the next question. Okay, I am in a bit speedy manner. Okay, but at any point of time, if any student has any doubt, then you can unmute yourself. You can ask me. You can use the chat box. Okay, but if you are clear enough, I am assuming, then we can move forward. Try to answer this particular question. Select the code snippet which performs unordered linear search iteratively. Unordered. It is a keyword, meaning that it has not been arranged into either ascending or descending order. So in that particular case, you are performing an operation which is linear search, visiting every element and then comparing whether the key or the element which you have to find is that particular element or not. So in that particular case, which is the correct pseudocode? Okay, pseudocode is a part of a code. Okay, it's a part code. It cannot be entirely executed, but it provides us the framework of how the entire code is functioning. Okay, so just try to solve. Okay. Yes. Shore is saying A, good, very good. Then Rule is showing A, good, very good. Yes. Okay. A, 4 A's, good. Yeah. Okay. Okay. Indeed, you all are correct. It is A only. Okay. INT, unordered linear search, then you are pushing the array as a parameter. You are receiving as a parameter the entire array, the size as well as the data which you have to just search. Then INT index is there. Then you are going through a for loop. If array I equal to data which you have to search, then directly you have to go on for checking its index. You have to supply the index and then you have to break through the loop. Okay, else the in the other options there is some mistake. Okay, that we'll just see. Okay, yeah, step by step analysis we'll just see. Linear search is a very simple searching algorithm. It checks each element of an array one by one until it finds the desired value or the data or reaches the end of the array. For any unordered array, there is no specific order. Okay, so we must check every element in the sequence. Okay, Step by step analysis of given code snippets is there, analyzing this particular code. Okay, it is 100% correct because it is iterating through the array using a for loop. It is checking each element one by one. Here you can see that if array I equal to data, okay, then it stores the index of the found element. Yeah, it is doing so. One particular thing or one particular improvement which you can make in this particular code, you can initialize the index to a particular value. Okay, you can either initialize it to 2 1 or whatever you want to just say. You can initialize this particular index to any particular value which is finite, and then at the end you can compare, so that if by mistake, if array is suppose 1 2 3 4 5, and by mistake if the user inputs the value as 6 or 7, then you can raise an message that this particular element is not found in the entire array which the user has already input. Okay, so this particular improvement you can do, either initialize it to index to -1 before the loop to indicate if the element is not found. Okay, so this is particular thing. Okay, then option B is there, int unordered linear search. Okay, yeah, this particular option, if you try to see, it is iterating through the array. Yeah, it is doing so. It is not storing the index. Okay, so how particularly it will be true, I don't know, but it will be incorrect. Okay, because if the element is find out, okay, if the element is found out, then in particular you have to just store its index. Okay, you have to store its index as, you have to make a statement, and likewise we have done in the previous statement, index equal to I. Okay, so yes, this particular is not true because it is not storing in the index before it is breaking the loop. Okay, and neither it is initializing index to any thing. So just declaring an index will raise a undefined behavior error. Okay, option B won't be correct. Option C is int unordered linear search. Then you take array as the input, size and the input, data as the input. Yes, int index is there, then you are iterating through the loop. Yes, it is correct. Then if array I equal to data, yeah, it is also correct. You are storing the index, but then you are writing continue, means what you want to do, you just want to go in the loop, so it will just make it a case of infinite loop. Okay, so when it is yeah, another array which is having I less than equal to size, it is always reason out of bounds error. Okay, I should be less than size, less than equal to size, no, it won't be there, because in case of your C language the index starts from 0, so it has to be less than size. Okay, and when you will calculate the size, you will always increase it by one value. So I should be less than size, not less than equal to. Okay, because no particular element has been stored at the index, which is array and in bracket size. Okay, at an index array size -1, an element would be there, but exactly at the size no element would be there. Okay, using continue, no. After storing index, making it all occurrences instead of stopping at first match, no. Continue won't be there. It would be break. Okay. Yeah, returning index, it is not there. Okay. No particular thing is there that it is returning any particular value. Okay. Yes, option D is there, 100% correct. Option D is none of the above. It is 100% not there. Option A is correct. Okay. uh, Partially correct, almost correct. Okay, needs just a minor fix, which is this particular one. You can initialize it to a known value. Okay, then at the end you can compare if index is -1, if index equal to -1, then you can raise a message that this particular element is not found. Okay, this is in total the explanation. Okay, something beyond the options also I have told you. Okay, just to improve the structure of the code. Okay, yes, linear search, how it is working, we will just see with this particular example. 58139 is an array, Then data equal to 3 means this particular element we have to find out. Okay, this is how you can give the input to this particular code, okay, which already was there in the first option. Yes, then you iterate it to one by one. Okay, one by one element you will try to see. For example, at index 0, the element which is sitting is fifth. Okay, is it a match? No. If at index 1, index will keep on increasing one by one, and every time it would be compared with the element which has to be found out. Okay, that is the only thing. So yes, at index 3, 3 is found out. Okay, so directly we will just say, okay, that at index 3, I will print the index also and we will print the element also. That is the thing. Yeah, time complexity of linear search is big O notation 1. Okay, best case, worst case it is n. You have to iterate through all the elements. Okay, that is the thing. Correct option, yes, A is there as well as the entire explanation in case of linear traversal, how things are happening. Okay, then unordered, iterative, time complexity, everything is there, and the correct option would be A only. Okay, this is the thing. Yes, Rishi, please, can you clarify one question? And yes, please ask whatever you want. Yes, anybody else? Any doubts? It was fairly easy. Just you have to look in the pseudocodes. Okay, looking into the pseudocodes, then telling me. Last session, one question, sir. So why didn't you ask in the last session only? Ask it in total. Okay, I am just continuing because I am just have a lot of things to explain. And at the last or at any point of time when you are clear with your question, then please do ask me. Okay, keep on writing. Yeah, let's move forward. Okay, what is the best case to the and the worst case complexity of the ordered linear search? In the previous question, it was unordered. And in previous question only, I told you what is the correct answer to this particular question only. Now it is just a test that how attentive you are. Okay. If you are fairly attentive, very easily all the students would be able to tell the answer. Okay. Very easy. Not in your slide that question. Then please give me the question. Use my email. Give on my email. Okay. Whatever thing you want to ask, please ask. Okay. Not in your slide, sir. Last one question, sir. From these particular two statements, I cannot get what you exactly want to ask. Okay. Yes. The rest of the students are saying it perfectly fine. It is D only. Okay. Please try to answer. The rest all should answer this particular question because I have already taught you this. Yes. Very good. Be attentive. That is at best what I can tell you. These things are complex. These all the things you will only get with practice. Okay. I am presently doing PhD, and still these particular things which I learned in the basic courses, they still are bit handy to me. Okay. So there's concepts, particularly the complexity, time complexity, space complexity, very, very important for you to understand. If you are having any bit of thought that you will be joining some research industry, or you will be going through into some startup, into some company which is going to pursue research and development, then this particular concept is very, very basic, very, very important to you. Okay, big O notation. Any point of time you are having any doubt, then please do ask me. Entire through your research career or something in which you are involved, which has to do something which research and development means, making new algorithms, making new concepts, everywhere this particular concept is dealt. Okay, very, very important. Indeed, this is big O notation 1 and big O notation n, because all this particular concept I already taught you. Okay, in case of your ordered is linear, in case of your previous question it was unordered linear sets. The worst and the best complexity is big O notation 1, okay, and big O notation n. That is the thing. Linear search is simple searching algorithm. It checks each element one by one until it is finding the target element, key element, or reaches the end of the array. Okay. In an ordered array, linear search still scans elements sequentially, but it may terminate early if the current element is greater than the search key. Okay. Best case complexity is big O notation 1. Best case occurs when only the first element it matches with the target element or the key element. Okay. In this case, the search completes just one comparison, single comparison, the search will end. Okay. It is a constant time or big O notation 1. Okay. Worst case complexity is big O notation n. Okay. Worst case occurs when the target element is not in the array. Okay. Full entire array has to be scanned. That is big O notation n. Okay. Target element is the last element in the array. Both the cases we must check all the n elements leading to big O notation n time complexity. Okay. Analyzing the options, rest A, B, C, all three are incorrect. The correct option is D only. Please do remember. Okay. Already I have taught you this particular concept. Okay. Not stressing much onto it. Moving forward. Okay. Yes. See this particular code. Okay. This particular is the code for ordered ordered linear search. Okay, this particular is the code for ordered linear search. Okay, int ordered linear search, int array, int size, int target. These all the three parameters it will receive. It is assuming that it is an ordered linear search. Okay, for int I equal to 0, I less than size, I plus plus. If that particular element is equal to target, then return the value of the index. Else if array I or the element, okay, of the array is greater than the target, then you have to just break. Okay. Else you have to return -1 if no element is found. Okay. A function can only return one value. So either it will return -1 or it will return the index or as well as the element of the array. Okay. And then we have created a function to print the result of the entire search, as well as in the inside the main function we have just given the input of the array. We have found the size of the array and we have just printed the number which has to be searched is this one particular one, and then the entire code is functioning. It is iterating through the array from index 0 to size -1, checking if the current element matches target. Okay. If it is early stopping condition is this particular one. If the element of the array is greater than target, then you have to break the loop. Okay. It optimizes the search compared to an unordered linear search. Element is not found, then you have to return -1. Yeah. Okay. This is the thing. Then this is the correct option, which is big O notation 1 to big O notation n, analyzing the time complexity of ordered linear search in both best case and worst case scenarios. Okay, this is the thing. Then sorted array linear traversal is there, then optimization is there. Okay, entire thing is there. Okay, yeah. Best case is big O notation 1, worst case is big O notation n. This is the explanation. Okay, in brief summary, okay, of all the things which I have said to you is here in this particular slide. Okay, you can go through it. Moving forward, binary search can be categorized into which of the following: brute force technique, divide and conquer, greedy algorithm, or dynamic programming. Yes. Yeah. Okay. Yes, Rishi, this question which you have sent to me, I'm giving you an email. Okay. On this particular email, you can send your question as well as whatever you other doubts you are having, you can contact. Okay. Here I am not having much facility to interrupt in between and then see your question, because simultaneously I am recording the session, I am monitoring everything. That is why I am giving you a mail. Okay. On that particular mail, you just paste this particular link which you have done, given to here in the chat box, as well as these all the options, and then I'll, after the class is over, I'll reply to you. Okay. This is the thing. Yes, indeed, all the options which you have, all the people which you have answered this particular question, they are 100% correct. Already I taught you this. Binary search works on the concept of divide and conquer. Okay, that is the only concept which is there. Okay. Understanding the binary search categorization, binary search is a very efficient algorithm. It works repeatedly, dividing the search space in half until the target element is found or the search space becomes empty. Okay, binary search allows a specific problem solving strategy. Analyzing to which one it belongs to. Brute force technique? No. Brute force means it's a particular concept. Okay, in your searching algorithms. How is it functions? It tries to calculate all the possible solutions until you are finding the answer. For example, in case of your linear search, checking every element one by one, that is a example of brute force approach. Okay. Binary search does not fall into this particular category. Okay. Divide and conquer. Yes, it's a strategy where the problem is divided into smaller sub problems, solved individually and then combined for the final solution. Binary search follows this particular approach, which is divide. Okay. Find the middle element. If the target is smaller, then search the left half. If larger, then search the right half. Okay. And then combining the solution. For example, in this particular array 10, 12, 15, 18, 20, if you are searching for 15, okay, starting in the middle, okay, just calculating the middle value, okay, and dividing it into the two parts. Mid value is only the 15, hence you have got your answer. Okay. So instead of scanning all the elements, it divides the array each time. That is why correct option is divide and conquer. Greedy algorithms make the best choice when at each step without considering the future consequences. For example, your Dijkstra algorithm, it is a greedy algorithm. Huffman coding is there. It's a greedy algorithm. Binary search does not work on greedily. Okay, these all the concepts you will be dealing with. Okay, in your later classes. Okay, as well as these are some of the advanced concepts. Dijkstra algorithm, if I have to explain you, it is a solution to a path planning problem. Okay, and it comes under the subject which is graph theory. Okay, entire semester course is there which is graph theory. In that particular course, this particular concept is dealt, which is Dijkstra algorithm, A star algorithm, TSP combinatorial problem, as well as other problems. Okay, this is the thing. Yeah. Okay. So greedy algorithm is not there. Then another option is dynamic programming. No, it is also not there. It has overlapping sub problems and optimal substructure. No, it is not there. Dynamic programming is another concept which is used to deal with the some overlapping sub problems and optimal substructures. Okay, when you have to just find the optimal solution in the entire search space, then you can go for the dynamic programming. Okay. Hence, it is incorrect. The last, which is option which is correct, is divide and conquer. 110% it is correct. Okay. Yes, this is in brief whatever I have spoken till yet. Okay. Still, if you having any doubt, then you can see it. Dividing means breaking the problem into smaller sub problems, dividing the entire search space in half. Okay. Conquering means solving the sub problems recursively. Sub problem is small enough, it is solved directly. Okay. Then combining the solution to all the sub problems to solve the original problem. That is your divide and conquer approach. Okay. Rest of the options are not correct. Hence, correct option is divide and conquer. Told you the explanation. Let us move forward. Given an array ARR equal to 45, 77, 89, 91, 94, 98, 100. Key is 100. What is key? Key is the element which has to be found out. What are the mid values generated in the first and second iteration? Okay, this you have to find out. Yes, Rishi, I'll just check in the mail after the class and then I'll reply you on that particular mail, whatever query you are having. Okay. Yes. Do try to solve this particular question. Try to see the array yourself, then try to calculate what the mid values you will get in first and the second iterations. Try to see them. Yes. Array has been provided to you. Mid values you have to just calculate. Apply the concept of the binary search. Okay. Key is 100. What shall be the option? That is the thing. Okay. Some people, nearly 80% are saying A. Good. Two students are saying C. Okay, very good. No problem. Okay. Any more opinions? Any more opinions? Anybody else will like to give his or her opinion? Feel free to answer. No penalties there on the answering. Okay. Yes. Indeed, the correct option is A only. It is not C. Why is it not C? I'll just give you a brief idea here. Okay. Try to give you the explanation. Why is it not C? I know that there are only two possibilities in which the students will get confused. Either I will say 91 or 98, or he will say 91 and 94, because 94 and 98 have got just no inference here. 91 and 100 are the two ends. So he will get confused between A and C only. Okay. We'll see through the explanation. Okay. See, for first of all, you have to understand how binary search is happening for given array. And now you have been provided a sorted array, which is 45, 77, 89, 91, 94, 98, and 100. You need to find this particular key, which is 100 in case of your binary search. Okay. And determine the mid values for the first and second iteration. Rishi, you are muting, then unmuting, then what you want to say? Your mic is very noisy. Please don't unmute yourself. If you want to say, use the chat box. Particularly, this information is conveyed to Rishi because your mic is very noisy. Okay. If you want to ask anything, then ask. I'm waiting for you. If you don't want to ask, then let me continue. Okay. Yeah, we need to find out the value which is 100 using binary search and determine the mid values for the first and second iteration. Step by step execution we will just see. First of all, 0 is the first index and right index, last index is 6. Count the number of elements and then start indexing from 0. 45 is 0, then 77 is 1, 89 is 2, 91 is 3, 94 is 5, 98 is uh sorry, 0, 1, 2, 3, 4, 5, 6. Entire elements are there. Okay. Yeah, that is the last index. Okay, then you find out the mid index. Okay, because total how many number of elements are there? Elements total are 6. Elements total are 7. Okay, so 7 number of elements are there. If you will start from 0, the indexing will be right now till 6. Okay, 0th element will be 45, 6th element will be 100. Okay, find out the mid value. 0 plus 6 divided by 2, that is 3. What is the 3th element? What is the 3rd element? 91. 0, 1, 2, 3. Try to count yourself. That will be 91. Is 91 less than 100 or 91 greater than 100? That the algorithm will compare. 91 is less than 100. Okay. Hence, it is moving towards right half. Okay. This is the thing. Okay. Then it will go to the second iteration. Okay, finding the new mid value. New mid value, how it will find? It will try to sum up the indexes of the first and last values of the right half, that are 4 plus 6 divided by 2, which is 5. Okay, so what is the fifth element? You try to see fifth element is 98 only of the array. Okay, so first mid value which it found in the first iteration is 91, and the second mid value which it found in the second iteration is 98. And the correct option is 91 and 98. Okay, this is the correct option. No confusion is there. Okay, everything is going on through the formula. Okay, this is the entire pseudocode, not the pseudocode. This is the entire complete codes for your iterative binary search or and you as well as your recursive binary search. Whatever thing I just explained you how it is going, either picking up the left hand part or the right hand part of the array while finding out the middle index, that particular concept is there. Okay, so function for binary search, then avoiding integer overflow, then finding the element, returning the index, searching in the right half, searching in the left half, then pushing the entire array, okay, through a main function. Then you go for recursive binary function, then it is either left is part is greater than right, then you have to return any return index which is -1, then you have to calculate mid value. Then inside only using nested if loop, we have found out that we are calling function inside a function. It will also work, but it will increase the complexity in case of your a large number of arrays. Okay, 2 raised to power n. Okay, this is the thing. But in case you are going with the iterative binary search, it is having much lesser complexity, time complexity. That is the thing. Okay, sir, how 6 plus 4 by 2 comes? Okay, this one 6 plus 4 by 2. Okay, I'll just explain you, no problem. See here, I'll use my this particular pen and paper. I'll explain you. This one was the array. Okay, so I'll just keep on mentioning the index. I already have taught you this particular concept that whenever you are provided an array, write all the indexes above it. Okay, so you will never get confused that which oneth element is which one. Okay, this is the thing. So entire array as in the cell we have just seen that 0th element of the array is 45, sixth element is 100, then fifth element is 98. Okay, so similarly all the elements first we have seen. Now you try to sort it using the binary search algorithm. Okay, initializing the pointer, which is left is 0th element and right one is the last index, which is the sixth element. In case of your first iteration, what it will try to do, it will try to find out the mid value using the indexes only. It will not take the value, it will always take the indexes. Okay, so first index at the left hand side, or the initial index is 0, last index is 6. Okay, so 6 plus 0 divided by 2, that is the 3, that is absolute value is 3. So it will go for the this particular third element. Third element is 91. Okay, this was the first step, first iteration. Then it is looking through either the first half or the second half. It will just see it based on the comparison between the mid value and the value which it has to just try to find out. Okay, so if the mid value is 91 and the value which it has to find out is 100, so definitely naturally it has to go and look on through the right half, because all the elements are arranged in an ascending order. That is the prior condition, either ascending or descending. So accordingly we will write, by default it is ascending only. Okay, accordingly we will write the code. That is what it is there. Okay, up to this much I think it would be clear. Now the next step. Okay, next step is, if it has to look in the right hand half or the right half, because the elements are arranged in ascending order, then the mid value it will again try to calculate. Okay, first of all the index was this one, which is third particular value, which is 91. Okay, in the second iteration it has left that particular elements, then it is coming 4, next element which is 4, and the last element. Okay, last element is 6. So 6 plus 4 divided by 2, that is 5. And what is the fifth element? That is 98. Okay, now your mid element is 98. Since 98 is less than 100, then it is again moving to the next half. Okay, and then when it is calculating the mid value, it is just leaving one element, that is left element would be mid plus 1. Okay, mid plus 1. So mid plus 1, in this particular case mid is coming as 5, so 5 plus 1 is 6. So exactly at the sixth element our value resides, which is 100. Okay, calculating the mid values, that is the only concept. Okay, how you will calculate the mid value? First of all, you will take the entire array, you will take the initial index, last index divided by 2, then calculate the mid value. Then you have to calculate, either decide you have to move to the right hand side or you have to move to the left hand side. If you are deciding to move to the right hand side, you have to definitely leave one index. Okay, then you will frame another array, then you will try to calculate its midpoint again. Okay, because you have left the entire left hand side portion. That is why we are doing 4 plus 6, otherwise we would have done 3 plus 6. Okay, not again searching through this particular left hand side portion. Okay, that is why it has come to 4 plus 6 divided by 2. Left is only mid plus 1 index you always have to calculate while you are calculating the initial index. Okay, of the finding the midpoint of the entire search space. Okay, is it clear, Steven, or still some confusion is there? Yes, it is clear. Okay, definitely. Any point of time, if any student is having any doubt, feel free to ask. Okay, no problem is there. I'll be explaining you in easiest manner it is possible. I have created slides in this possible manner only. Okay, so that even if I'm not there, entire thing is there at a glance. You can always see before the examination. Also, it would be much more helpful for you. Okay. Then analyzing the time complexity, because we have just taught, we have just learned this new concept, which is the time space complexity, time complexity. So best case is this particular one only, that our first case is correct. Okay, we have just calculated the mid value and we have just found out that the mid value is the only value. Okay, so it is big O notation one. Worst case, you have to do a full binary search and the last element is what we were trying to find out. Okay, in that case, it would be log n. So it is 0 to log n. Okay, this is the thing. Yeah, and it will work much faster as compared to linear search because it is splitting the entire array into two halves. Okay, that is the thing. Yeah, correct option is 91 and 98, as well as here we have found out the mid values again. Then comparison we have done. Then we have iterated, then found out 91. Then in iteration 2, we are doing 4 and 6 divided by 2. That is fifth index. Then 98. Okay, that element we are having. Then if 98 is less than 100, we are updating it as 6. Okay. Then at iteration 3, we are getting array value as 100. Okay. This is the entire explanation in brief. If you want, you can just go through it. If you still you are having any doubt, okay, you can feel free to go through it. Okay. This is the thing. Moving forward, okay, select the most appropriate pseudo code that performs selection sort. Try to solve. Go through all the codes A, B, C, and D. Then tell me which one is the most appropriate when it comes to selection sort. Okay. Try to revisit all the options. Okay. See which one is the most appropriate pseudocode when it comes to performing the selection sort algorithm. Okay. Not insertion sort, it is selection sort. Okay. That is the thing. B. Okay. Then A. Good. Very good. Two students have answered it. Appreciating your effort. Okay. B, then A, then B, then A, then B, then A. Good. Very confusion between A and B. Okay, no problem. Okay. Rest other people, any opinions on this question? Hey, good, very good. Yes, definitely. It is 100% true that it is A only. Okay, it is not any another option. We'll look at each and every option. Okay, we'll see. Yeah. Then understanding the selection sort pseudocode. Selection sort is sorting algorithm. It repeatedly selects the smallest element from an unsorted portion of an array and it swaps with the first unsorted element that I already have told you that how that particular selection sort procedure is there. Okay. Sorting algorithm, it repeatedly selects the smallest element from an unsorted portion of the array and it swaps it with the first unsorted element. That is the thing. Correct selection sort steps you include initializing minimum as the index of the first unsorted element, then finding the minimum element in the remaining array, swapping the minimum element with the first unsorted element, then repeating the entire thing for rest of the array. Okay. Option A was this particular one, int min, then int j equal to 0, j less than your array length minus 1, then j plus plus, then minimum equal to j, then entire thing is there inside a for loop for j, k equal to j plus 1, k less than equal to array length minus 1. Yes, you have to reduce this by 1. Okay, then k plus plus. If the array element, okay, here we are indexing an element using the letter k, that is why the kth element is less than the minimum element, then you would swap it. Okay, otherwise everything will try to be on its own. Okay, then every time you have to keep on swapping. It correctly finds the minimum element of the in the unsorted part, it swaps it with the first unsorted element, and it is having a proper local bound which is k less than equal to array length minus 1. Okay, so valid comparison would be there. What happened in case of your option B? In case of your option B, particular mistake is here. Okay, k less than equal to array length minus 1 should be there. Okay, or okay, it should be array length minus 1, hence it is not true. Okay, or less than equal to symbol you remove, either two options are there. C and D both are having a RRK greater than array minimum. It finds the maximum instead of the minimum. Okay, so the entire concept or the idea of selection sort becomes opposite here. You have to just find out the minimum in case of your selection sort, but here you are just trying to find out the maximum. Okay, so hence option C and D will be totally eliminated. B got eliminated because of k less than equal to array length. It should be length minus 1. Because of single minus 1, B option is incorrect. Correct option is A only. Okay. Go through the entire pseudo code. Entire code is also there, step by step. Try to write it down either in your notebook, either in your compiler. Try to run it down. Thereby, you will get a confidence in your examination. Okay. This is the thing. Yeah, this is the entire explanation. Okay, why it is correct. Outer loop is there. The outer loop iterates through every element, one element at a time, identifies the minimum, puts it into the spot, then finding the minimum index in each iteration loop of the outer loop. It assumes that the current index has the minimum value. Then inner loop then iterates through the remaining unsorted portion of the array and finds the actual minimum value. Then swapping is taking place after the inner loop finds the minimum element, swaps with the minimum element at the correct index of the outer loop. Then you try to analyze the pseudocode. Okay. A option is correct. B, it got incorrect because of k less than equal to array dot length. Okay. It should be array length minus one. Then C is obviously incorrect. D is obviously incorrect because it is just changing the entire logic. Okay. Hence the correct option is A only. Okay. Yes. Consider this particular question. Consider the array A within square braces. Okay. It is written 72615. Apply insertion sort. Which particular algorithm you will apply? You will apply insertion sort. Sort the array in the ascending order. The cost associated with each swap operation is 20 rupees. What is the total cost when the element 1 reaches the first position of the array? That you have to find out. Okay. Try to answer this question as well as the next question. This I have formulated. This you will not find out anywhere else. So whomsoever are answering it correctly, they know the concept in entirety. Okay, Aman is very swift in answering the question. Very nice. He's saying B. Good. Rest all try to calculate. Okay, take your time. I'm giving you 2 full minutes. I'll just be joining. Okay, take your time. Then answer. Try to calculate first. Then try to answer it. Okay. Yeah. Yes. Okay. Lot of opinions are there. Very good. B, then C, then C, then D. Why nobody is saying A? Let it be an option also. Only one is correct. And I like to say that Shaurya, Aman, Sayan, Rakshita, then S Sharmitha, then Aman, then Rajesh, then Roli, then Sayan. They all are correct. Okay. Yeah. It is C only. Okay. Why is it C? Go through it. Okay. With me. Let us see each and every step. Okay. Then you try to analyze it. Okay. Try to think whether we are doing it correctly, not correctly, how it came 60. You should be very well aware with it. Okay. Yeah. We need to apply an insertion sort to this particular array, which is 72615. This is the array. Calculate the total cost when element 1 reaches to the first position. When calculate the total cost when element 1 is reaching to the first position, that we have to find out. Then obviously we have to step by step execute the insertion sort. Okay. So entire array is this one, 72615. We go element by element, insert them at the correct position. First of all, we'll select insert element, which is least one, that is 2. 2 we will just see. Okay. 2 at the correct position means we just swap. Okay. Hence the total cost in swapping 2 with 7. Okay. That is the first swap we have performed, that is 20. Now in iteration 2, now 2 and 7 are dealt. Next element is 6. Okay. Okay. First element we have left, then second element we have just swapped. Okay. 2 and 7 we just have swapped. You already must be knowing. First element it takes as it is. Okay. It thinks that it is correct. Then it goes to the second element. It swaps it. 20 rupees we have spent. Now we will go to option which is 6. Now 6, the option which was 6. Okay. So when you will just see the element 6, it will be swapped with 7. Okay. Because it is in wrong order. After 7 it is written 6. So 6 and 7 will be swapped. So one swap it is again costing me 40 rupees. Okay. So far the cost has been 2020, which is 40 rupees. Now at step 3, inserting 1 at the correct position. Okay, inserting 1 at the correct position. And what would be the correct position? Okay, comparing, uh, you just try to compare 1, this particular element, with rest of the elements. Okay, so 1 will be compared with 7, swap cost is 20 rupees. 1 will be compared with 6, swap cost will be 20 rupees. 1 will be compared with 2, swap cost will be 20 rupees. So entire cost is 20, 20, 20, which is 60. Okay. Total cost so far has been 40 plus 60, that is 100 rupees. Okay. So one has attained the uh, first position. Okay. So in the question, what I asked, what is the total cost when element 1 reaches the first position in the array? Just for the element 1. Just for the one first element, not the entire cost which was involved previously. Okay. So total cost just for this particular element 1. I'll write it here itself. Okay. Don't get confused. What is the total cost when uh, the element 1 only, okay, only the element 1 reaches the first position of the array. Okay, just for total cost, just for the element 1. Okay, when just the element 1. Okay. Okay, reaches the first position. Then for swapping the only the element 1, only the element 1, the total cost is 60. Okay, but in entirety if it is asked to you, it is 40 plus 60, that is 100. Okay, which is not even an option. Okay, so here you just have to go with this particular option, which is 60. Okay, this is the thing. Okay, this is how your entire insertion sort algorithm is function. Okay. Yes. Please repeat the iteration. Okay, I'll repeat the iteration. Okay. Iteration number 3 you want to repeat? Okay, I'll repeat. I'll repeat it in total. Okay. No hurry is there, no problem is there in repeating. I'll repeat every iteration. First of all, we have the prior condition that we will leave element 1. Element which is there at the first place or at the index number 0, we will leave it. Okay, we will leave it. We will just begin our swapping with the second element. So the second element of the array was 2. Now we look both the first element, second element, 2 and 7. Okay, 2 is less than 7, then that is why we have to swap both the elements. So we just swapped it. The cost was 20 rupees. At the iteration number 2, now we have iteration 1 is over, iteration number 2. Now the next element, okay, 2 we have seen, means this first index or the second element we have seen. So the third element is 6 1. So 6 will be compared with the adjacent one. So adjacent one was 6, adjacent one was 7. So 6 is less than 7, hence you have to swap both the elements. So total cost at this particular step is 20 plus 20, that is 40. But at iteration 3, the structure of the array is 2 6 7 1 5. Okay. So this one, which is there as the fourth element of the array, that will be compared with the all the elements which were there prior to it. Means the first, second, third element we have to compare accordingly. If it is less than them, then we have to swap. Okay. So comparing 1 with 7, okay, then directly you have to swap. Okay, because 1 is far less than 7, I already know. Hence the swapping is 20 rupees. Then you compare 1 with 6. It is also there. Okay, 1 is less than 6, then directly you have to swap. Then 1 at the last will be compared with 2. So directly you have to swap. This operation you will end when the comparison operator is uh, the condition for the comparison is not satisfied. The number which is getting compared, it should not be less than, it should be greater than or equal to, then we have to just stop the swapping condition. Hence in total, three places, for three places we have swapped, one with all three rest of the numbers, one with 7, as 1 is less than 7 also. Then 1 was there at the third place, then also we have to swap it with the second place because 1 is less than 6. Then when 1 was there at the second place, then again we have to swap. So then 1 got at the first place. So in three different iterations, that is, in total cost, the swapping was 20 plus 20 plus 20, that is 60. In total, the cost would be 60 rupees. So in total, what is the total amount? Which is 40, 40 into initial, and then at this iteration it is 60. So in total 100 rupees we have spent, but just for the iteration 1 it is 60 rupees. Okay, this is the explanation. Is it clear to you, Aman, right now? Or still, if any doubt is there, feel free to ask. Okay. Okay. Yes. Okay. Good. Next, we will move forward. This is the last question for the present session. Find the output of the following C program, and this is your C program. Entire code is there. Insertion sort algorithm code is there. Okay, and we have just inputted, given input, okay, as an array 12 5 8 3 10. Okay, and we have kept as 5, then I j temp we have declared these all the variables, and inside main only this entire thing is running, insertion sort algorithm is running. Then after sorting, an array is getting printed. Okay, so please do try to answer it. Okay. Okay, Aman is saying C. Good, very good. Okay. Four people have answered it C. Okay, no problem. Yes, indeed, you all are correct. Okay, the correct option is C1 only. Okay, 3, 5, 8, 10, 12. Okay, directly you can evaluate. It's a simple insertion sort algorithm code. Even if I have removed it, you could have easily seen. Okay, very easy to see that comparison is getting taken place. Okay, here, and whatever the logic I have told you, that is directly being performed here. After the code is executed, you will definitely get the sorted array, which is 3, 5, 8, and 12. Okay, there is no twist. Although in the examination some twist might be there. Okay, even if I change only single value here, if I write j equal to I minus 1, that line is there. Okay, if in that place I write j equal to I plus 1, entire thing will be something else. Okay, so be very mindful in the examination while executing a particular code in your copy and pen. Take it as iteration wise, step wise. What is happening in first iteration, what is happening in second iteration. Here I have been provided only 2 hours of time, that is why I have prepared slides. Else I would have just solved the question on the blackboard in front of you, step by step. Then you would have got the idea that how I am solving. Similarly, in similar pattern you can solve. Okay, but I am providing you the slides, so it is now your responsibility. All the output questions practice multiple times. Okay, get good marks. For getting good marks, for understanding the concepts, it is very very important to solve all the output questions. Take a copy and pen, try to solve. Okay, every iteration you have to solve, you have to write it down, as well as how indexing I am doing, similarly you have to do. Okay, that is the thing. Yes, understanding the given array. Initial array is this particular one, 12, 5, 8, 3, 10. N is 5. Okay, insertion sort works by picking elements one by one, placing them in correct order, and in the sorted portion of the array, executing insertion sort and iterations. Go through each iteration in detail. Iteration 1, insert 5 at the correct position. Temp is equal to 5. Compare it with 12. Insert 5 at the correct position. Temp is equal to 5. Compare it with 12. Insert 5 at the correct position. Temp is equal to 5. Compare it with 12. Insert 5 at the correct position. Temp is equal to 5. Compare it with 12. Okay, yes. Just a second, guys. I just got disconnected. No problem. Some issue was must have been there. Yeah. I was explaining you the last question. Okay. Yeah. I understood. Is it audible now? I just rejoined. Some connection issue was there. I got it. Yeah. Okay. No problem. Yeah. I was explaining you. I'll explain it from the beginning. I was explaining you how this particular selection sort, how this particular insertion sort algorithm is performing. Okay. This is what I was explaining you. Okay. Understanding the given array, which is initial array is this particular one, which is 12, 5, 8, 3, and 10. Then n equal to 5 is there. Then insertion sort is works by picking elements one by one, picking them in the correct order, then in the sorted portion of the given array. Okay, that is how it works. First of all, it will insert 5 at the correct position. If temp is equal to 5, it will compare it with 12. 5 is less than 12. It is shifting 5 at index 0. Okay, this is the thing. Then inserting 8 at the correct position. Okay, it will be just comparing it is less than 12. Then it will be swapping it with the index 1. So then you will get 5, 8, 12. Then inserting 3 at the correct position. Okay, it will be comparing with 12. Then it will be shifting it with 3 and 8, then 3 and 5. Okay, so now you will get the element 3, 5, 8, and 12. After the end, you will get inserting 10 at the correct position. Okay, comparing it with 12, shifting it with 12, shifting 10 with 8. So there is no need to shift. Then insert 10 at the index 3. So hereby you will get the entire sorted array, which is 3, 5, 8, and 12. Okay, then you are printing the output, and the correct output is 3, 5, 8, and 12. Okay, this marks the end of the present session. Okay, thank you all for joining the session. If you are having any doubt, feel free to ask. Rest you can kindly leave. Do join the session next week. Okay, same link, same time. Okay, thank you all. Thank you, sir. Thank you, Aman. Thank you, everyone. Okay. If you are having any doubt, feel free to ask. I'm here for a few more minutes. Rest you can kindly leave the session. Okay. Yes. Thank you. Thank you, Rishi. Sir, can you provide your GitHub account? What you will do with my GitHub account? Sir, can you please show second answer? Okay. Thank you, San. Yeah. Roli, please specify. I'll provide you, no problem. If you want to do ask in particular anything, then you can ask. Okay. Otherwise, please specify in more detail. Yeah. Sir, can you please show second answer? Okay. Question number 2 or this particular question second answer? Please clarify. You are talking about question number 2 or this particular question's second answer? Sir, sorry, not second, fourth one. Fourth question, right? Okay, fourth question. Okay. Yeah, I'll check your email. No problem. I'll reply as soon as possible. Don't worry. Let me bear with the class first. Let me end the class first. Then this particular one, fourth question, Steven. Yes. Yeah, I can show you, even though you can access it in this particular link. Okay, I'll provide the PDF just after the session is over. Okay, so you can go through this link. What you specifically want to ask, anything you want me to repeat, please tell me. Okay, I'll do it for you. You want to repeat me, or you just wanted to see anything? Any doubt, specific doubt is there, then please tell me. I'll repeat it also. Yeah, you want me to explain it once again. Okay, I'll explain you, no problem. This particular code is about unordered linear search. First of all, what is linear search? Linear search is an array has been provided to us. Okay, an array has been provided to us. Okay, for example, array like 1 2 3 4 and 5. This is a sample array. Okay, so this particular array has been provided to you. So it is an ordered array. Okay, for example, another array 2 1 3 6 8. Okay, this particular array is unordered array, means neither it is in ascending order, neither it is in descending order. So this particular arrays are known as unordered array. Okay, so now you have to perform a linear search iteratively on an unordered array. Okay, linear search means you just have to take one particular element. Okay, linearly you have to keep on searching through entire array, means you have to take one particular element of the array, then you have to perform the comparison. Search array means finding that element in the entire array which we have been provided. That is the linear search. Okay, linear search entirely iterating through all the elements and then performing the comparison. If you are getting the element, it is fine. If you are not getting the element, then you have to return any message that sir, we don't have found out your element in the array. Simple operation. Okay, now you try to see this particular a code. It is function has been written int unordered linear search. It is taking three particular inputs, which are int arr, int size, then int data. Data is that particular element which has to be found out. Size is the entire size of the array. Okay, number of elements in the array, arr, and inside that no indexing is, no particular size we haven't defined. Okay, so array directly we are receiving. Now int index is there. This index is for accessing every element of the array. Same index of the array which I drew. Okay, there was an array over that I wrote the numbers from 0 to n minus 1, where n is the number of elements of the array. Okay, so int index is there for int I equal to 0, I less than size, I plus plus. Size is the size of the array. Okay, so for entire array, I am using a for loop, and then inside the for loop, if my array ith element of the array is equal to data, means directly performing the comparison whether that particular element which I need to find out, it is equal to that or not. If it is equal to, then I am telling, I am giving that particular index, I am storing that particular index in the variable index. That is why here it is written index equal to I, means whatever is the value of I, means at that particular place the element is there, so that will be directly transferred to index. Okay, then break statement is there. Break statement means you will exit from the loop. Then after that, an element, particular line has been written. Return index means you just have to return that particular index. Okay, inside the main function. That is the thing. So this is the correct option. This is indeed the correct option as it has been here. Okay. Rest all the options are incorrect. This is how you will perform the unordered linear search. Now I will tell you why other options are not correct. Okay. If you will just see the second option, okay, entire thing is good, looking good. Int index is there. I equal to 0 is there. I less than size is there. Then after if arri equal to data is written, then break statement is written inside the loop, but there is no storage of that particular index. So how you will be able to access that particular element? How you will be able to find out the index of the element which you wanted to search? So this particular exercise which we just did, that using a for loop and doing all these things, this becomes useless. So B option is not correct. While in case of C option, if you will see, yes, function declaration is good, then int index is good, then next line is good. Okay, then if condition you are applying, it is correct. Index equal to I, you are storing, but here we have written continue. So what will happen? The entire loop in it will be stuck in the entire loop only. Okay, means it will be comparing, then it will be if arri, it will get as if it will get the requisite data or a requisite integer which it wants to search in the entire array. Okay, it will store its index, it is correct, but it will still continue. Okay, so what will happen, you will always get a constant answer for this particular thing. Okay, so continue statement should not be there, it should have been break, otherwise it will just jump into the infinite loop. Okay, this particular condition will never be get ended. It will try to search on from 0 to that element, that particular index where the element has been stored. Okay, so continue will not be there, it will be uh, break. Okay, so that is the thing, that is why B and C are incorrect, A is correct. Okay, this is the thing. Is it clear to you, Steven, or still any doubt is there? Then please tell me. Okay, 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 Steven. Anybody else? Any problem? Any doubt? Anything? Okay, thank you. Thank you very much, Steven, for joining the session. Do join the session next week, same time, same link. Okay, thank you. Okay, if no doubt is there, I'll end the meeting here itself for all of you guys. Okay, thank you all for joining the session. Okay, do join the session next week, same time, same link. Okay, thank you all. Yes.